G'day everyone. Welcome to the Smart Energy Lab. And today I've got Kal from Delta Electronics. Good to have you here, Kal.
Really excited to be here, Glenn, and great to be here at this wonderful place.
It's been a bit of an adventure for you getting here today.
Oh, it's been quite interesting. So our Nissan Leaf climbing uphill decided that it was going to run out of juice very soon, so we drove downhill, coasted down and went to the RACV and juiced up, and here we are.
I like the fact you sat down at the RACV for half an hour?
Well, we thought we were going to be there for about 15 minutes.
Yep.
And it took us an hour to juice up 3 kilowatts. So it's like unbelievable. But now that we're out here and we've got the DC city fast charger from Delta, the 50 kilowatt, it's already charged up in 30 minutes. Wonderful.
I think more like 15 minutes actually. It was incredibly fast.
Yeah.
Yep. The problem I suppose is it's a type 1 port for AC charging, which is I think only maximum 3.3 kilowatts. So yeah,
that's right.
Really is a trickle charger.
We were limited by that. We didn't have the CHAdeMo connector down there at RSEV, so we couldn't do that.
Yeah. So you mentioned CHAdeMo, whatever people call it. I was checking out on Wikipedia how that name came about. Apparently it's a translation from the Japanese meaning a cup of tea. And the idea was that you can charge your car in the time it takes to have a cup of tea.
That's really interesting, but the amount of time it took us down there today was maybe brunch or lunch. But up here, yes, definitely a cup of tea.
Cool. Yeah, so it's been a really big game changer for us here at the Smart Energy Lab, having this 50 kilowatt DC charger from Delta. You asked me in an email question before this event about off-grid charging, and I guess for us it's always been a kind of thought that it would not be possible because of the amount of solar energy required to run a DC charger. But actually, because of the cheapness of solar panels now, we have got like about 110 kilowatts of solar connected here to the microgrid. So on a sunny day, we'll easily be able to produce 80-90 kilowatts of direct energy. The other thing that really helps is that the Delta DC charger is configured Delta, so perfect balanced 3-phase, which is great for off-grid inverters. They don't have any imbalance problems. So if the sun's shining, we can just whack on 50 kilowatts, no problem at all. And now that we've got 7 electric cars here at the Smart Energy Lab, or at the Co-op actually, where the lab's based, it's like I said, a game changer.
I mean, it's really excellent, Glenn, to hear what you've done here. I mean, I read about this article. We talked about that briefly earlier as well. Spud Murphy at the Roadhouse in Alice Springs, and he wants to put in their DC fast charging. And I thought this is a wonderful opportunity to share this with the Delta community, the wider community, and obviously your community as well, who check in regularly to your YouTube videos.
Well, Alice Springs have a secret weapon. It's called the sunniest place in Australia.
That definitely helps, Glenn. Definitely does, yeah.
Yeah, so, and long sunny days. So definitely would be a big plus if they had a reasonable size array to run a charger there. Basically, if it's daytime, plug in, no problem at all.
Wonderful.
Yeah.
Yeah. So
I'll have a look at the article again, or maybe I'll put a comment in for Spud to get in touch.
Yeah, probably he will, and if not others, we can reach out at some point and share this information with him, and hopefully we should be seeing some fast charging at Alice Springs soon.
Great. Yeah. So Kal, what's your role at Delta?
So Glenn, at Delta, I'm the Business Development Manager for EV charging solutions for Australia and New Zealand.
Right, okay. Now, you've been involved with DC charging for a long time, I believe.
Oh yes, my journey started about 30 years ago when I was actually building electric cars. 30 years ago is a long time, but those were actually for kids. I built the first one for my son. It was a replica Porsche 911. And at the age of 2, he was zipping around at 3 kilometers an hour. And as he grew older, I just put in 2 batteries and bumped up the speed to twice that. So it was 6 kilometers an hour. And it was easy enough to charge. Just plug it into your AC socket with a small adapter, and overnight it charges. So yeah, it was quite an interesting start to my sojourn into, let's say, EV charging. At that time, there weren't really big capacity batteries available. The motors were really small, so I got some motors out of drill machines and developed a reduction gearbox to reduce the RPM and put up the torque. And that's how I got it to work.
that's amazing. Look, I'm from New Zealand, and you just reminded me that my very first car when I was a child, 7 years old, was an electric car. But my dad didn't make it. We won it at a trade show, and it was like a little off-road vehicle about this big, with the lead acid battery in the back, and I drove it around the back garden. I remember saying to Dad and Mum, "Can I take it to school?" And they said, "Nah." So now we're back into talking about DC charging for everyone else apart from you, me, and your son. Where do you think DC charging is going for the average person?
Definitely, EVs are on the uptake.
Yeah.
I mean, right now it's like getting several inquiries per day.
Mm-hmm.
The market just seems to have exploded since the last year in the pandemic. I mean, with the pandemic, you would have thought that things would have slowed down, but that's not necessarily true. And fuel prices have gone up. People have started taking up EVs, and just not enough supply of the cars. But having said that, those that obviously can get the cars, they want chargers, and we're seeing more and more inquiries for that.
Yeah. It's a tipping point, I think.
Definitely.
People think it's only going to happen when electric vehicles are the same price, the sticker price, as internal combustion engine. But there's so many other factors.
Oh, totally. I mean, obviously, this is the environment. There's sustainability, and people's perceptions of what cars should be. Not everybody wants a noisy ICE car. Many people are happy with a nice quiet car and the journey that they have and the user experience. So yeah, it's a good time to be in this industry to see it really changing.
I mean, I've run a solar battery business for many years, and customers would often say, "I'm installing solar because I want to produce clean energy," and it's partly a feel-good thing for them that it's a little bit guilt-free then. So if they run their aircon in summer, they're not actually harming the environment if they've got solar that's covering that load. And I suppose the same could be thought of as transport. Like we drive up and down this mountain a lot, and it's guilt-free. Now it's an electric vehicle. We're not thinking we're wasting all this fossil fuel.
Of course. The other thing is also the interest from the governments, both Australia and New Zealand. We've seen a lot of incentives coming up in the last year, and that's also made a big difference. So it's good to see all of this now reaching tipping point, as you say.
Yeah. Can we get Auntie Jacinda to talk to our government, please? Because they're a little bit behind the eight ball when it comes to incentives.
Interestingly, New Zealand has done a very good job about this. Obviously, that's because of its persona about the green environment and the way things are. So that's embraced more wholly. But seeing the amount of solar installations here in Australia, and if you read the articles, about 60% of solar owners, they own or they want to have EVs. So that's a big step waiting to happen, because solar is much bigger in Australia than it is in New Zealand for obvious reasons.
Yeah, the climate is a big one, but New Zealand also has a really high renewable component of its grid, so there's not the kind of urgency as it is in Australia to get off the coal.
Of course.
Yeah, but you're from Auckland originally.
That's right, yes.
So I think last time I was in Auckland, which was about 3 years ago, they were talking about making one lane on the motorway for electric vehicles along with buses and taxis. Did that happen?
Not yet. I mean, there's a lot of discussion about what things could be and what's the ideal utopia, if that's the right word. We're still a little way off, but yes, that will happen. So the plan would be that as EVs become more prominent, so there's a bus lane, and they'll probably make that a bus and EV lane, if that helps in the sense of getting faster commutes for those who actually want to pollute less.
Yeah, certainly the congestion on that free motorway is pretty bad at times.
It is. Yes.
So that'd be a really big incentive. It's kind of like having Elon Musk's underground pipe to work,
Correct.
Yeah. So we've talked about fast charging, like the DC fast charger we've got here at the lab, but that's a big piece of kit. That's like 740 kilo unit. Is there smaller versions of DC fast charging?
Yeah, so Delta's got an entire range of AC chargers all the way to DC chargers. So the idea is to provide options for destination charging, which is typically the smaller AC chargers, and journey charging, which is the fast DC chargers like you have over here. So the AC chargers, they start from a single phase 3.46 kilowatts. The same charger can give you 11 kilowatts in 3-phase, and then it goes all the way to 200 kilowatts in DC fast charging. So we've got a good range of AC, not only for destination, but also for journey, like let's say cafes or wineries. And then you go into the DC kilowatt 25s and the DC 50s, which is out here at your lab. and then the 100 and the 200. So Delta pretty much covers the entire range.
People often say to me, service stations are going to be putting in fast chargers, and I'm thinking probably not, because you don't want to really spend time at a service station. You want to go and do other things with your life.
So there are two camps to that. So I mean, definitely the fossil fuel business is going to reduce, and then those properties that are already developed, obviously it's a good location for getting fast charging and for journey charging. And 50 kilowatt charger like this charger, leave today in about 15 minutes. A bigger car and a bigger charger like 200 kilowatts, you can do the same, almost a full charge in about 30 minutes.
I mean, I have seen the service centres along the Hume, for instance, putting in fast chargers.
Yes.
But I was thinking more that if you go to a supermarket, wouldn't it be a value add if you could charge there as well as do your shopping?
Of course.
And you're not waiting around for it to charge. Then you're doing something else.
Of course. I mean, if you look at the statistics, it's like about 7.21 from memory public chargers per each vehicle. So obviously for the uptake, we need more chargers and more locations. So it's going to be at different businesses, different venues, like you say, at the supermarkets or at cafes to attract customers. Maybe some places will even offer it free. Today at RACV, we charge it free. I didn't have to pull out my RACV membership card, even though I have one. It was just free. I just go there and we just plug it in. And again, you need them at different places. Otherwise, you can't encourage people to get into their EVs or buy EVs. So yeah, the more places it is going to be, it's going to be better.
So for charging at home, let's say you've got solar energy as well. Is there a way to optimize your solar to be preference to charge your car?
So interestingly, our chargers, the back end is called OCPP 1.6J or the Open Charge Point Protocol. And that's a standard protocol across chargers. What that allows the charger to do is, with the appropriate software, with the same protocol, you can have energy and load management, and also can sync up to battery storage, solar soaking, and those kind of benefits that you can get out of the charger. So the benefits of charging are numerous, and again, if you use an OCPP software, there are third parties available. Delta is compatible with all the third parties that subscribe to that protocol. You can have a wonderful solution, whether it's your home or it is your commercial site. Yes.
Could OCPP also link into retailers' plans? So you've got an energy plan which kind of turns on your charger whenever energy is cheap?
That's a brilliant observation, Glenn. That's definitely possible.
Yep.
So if the data feed is available, what the electricity is going to be at a certain time of day, and that software can then be programmed to pick the best required for that particular site. So not necessarily the cheapest is going to be the best time, because cheapest could be at night, but you also need during the daytime. So how do you optimize the demand versus the pricing? So that's all possible through the software. Yes.
Oh, cool. Now, you had a few questions for me, actually.
Yes. So I was really keen to understand what you're doing here, Glenn, at the Smart Energy Lab. I mean, this place it's wonderful. I never knew a place like this existed till we drove up the hill. So what do you do here in this place? And I know you do a bit of training, and so please tell us a bit about it so we can share with the community.
Yeah, I'm kind of an accidental facility. This started off as I was a TAFE teacher teaching at TAFEs in Melbourne, and I was teaching the standalone power system course and grid connect course. But for the standalone power system course, there wasn't really very good resources at the TAFE that I was teaching at. So I used to bring my students up here for a bit of real world experience. You could say it was the good, bad, the ugly. You know, some of the systems here are pretty old and cranky, and some were better. And my students would often do practical exercises on them. But more and more I realized that actually this was the value for me, was training people on real equipment. And it started with a few companies donating some systems here for my students to train on. And I left the TAFE network happily and started doing my own courses here. So non-accredited courses, just sort of professional development to for already qualified people in the industry, getting more expertise around the products that are available. But it's just snowballed. In the last 5 years, it's almost a weekly event that another piece of equipment turns up here, a battery, an inverter, charge controllers, smart energy management stuff. And now I've got 2 electricians on staff. They both live here, which is really convenient. And I'm kind of busy both making content like this about these products, but also training people online. So I do a lot of live online training, and I'm actually just starting to do pre-recorded training courses now. So that's kind of my story.
Oh, that's brilliant. Thank you for sharing that. I mean, it's great to see that you're training so many people. You've got a studio here and you're also taking it online. That's great. That's wonderful.
Yeah, and I suppose, being an off-grid community where we live here, I live and breathe solar and batteries. I'm effectively a mini utility. There's 7 homes connected to this microgrid, and if I go away for the weekend, I've got an app on my phone. I can just monitor it. I'm like the engineer at the power station going, let's make sure everything's working.
Yeah. Oh, wonderful. I mean, I could see some of the people coming through because obviously your shed here is the central location for whatever's happening. So it's good to see that. Yeah.
I think you saw my partner's daughter come to do her drying. That's right. Yeah.
Yeah, and once we get a chance, we'd love to step outside to look at a DC city charger and how you've taken it off grid. And of course, I'd like to introduce you also to our tech lead, Geordie, who's a field application engineer, and I'm sure he'll have some technical questions to ask about that, and maybe some insights you could get from him as to the other product ranges we have in Delta as well.
Great. Okay. Well, let's just do a chair shuffle and bring Geordie in.
Okay.
All right.
Thank you.
Thanks, Kal. Well, we've done a little bit of a chair shuffle here, and I've got Geordie, who also turned up in the Nissan Leaf, limping up the hill. So, Geordie, what's your role at Delta?
Okay, so I'm the field applications engineer at Delta, and I look after a range of different departments. So I do EVCS, PCS, and PVI.
Oh, no. Stop right there. That's a whole bunch of acronyms. Okay, EVCS, what's that?
Yep, so electric vehicle charging solutions, power conditioning systems, and photovoltaic inverters.
Piece of cake. So PVI, photovoltaic inverters.
Yeah,
excellent.
And that's my main sort of bread and butter.
Yep.
I do a lot of compliance, a lot of testing before things get released here in Australia. I work very closely with the R&D department for all those departments, and do a lot of integration work and working with third-party integrators.
So you must have been busy when 4777 Part 2 2020 came out.
Yes, unbelievably. Yes, for sure. I'm sure everyone's heard about DC isolators through that period of time, and we were kept very busy, but we all got through it, which was great. And yeah, glad to have gotten through that.
Yeah, the DC isolator test. So did you have integrated DC isolators?
Yes, we did.
Retesting?
Yes. Yeah. So we ended up with a declaration, and that was all fine. So we had everything tested as it should have been. It was just an administrative thing, really, to be honest. Yeah.
Yep. It nearly stopped the whole industry in Australia, though. It was touch and go.
Yeah, it was pretty frightening, and being part of some of the CEC meetings and watching what was transpiring. So I'm glad that it all got solved in the end.
Yeah.
Yeah.
Oh, good. All right. So you're back on track. You can sell the units, no problem.
Yeah, that's right. Yeah.
Oh, cool. So when you're not dealing with photovoltaic inverters, what's your sort of second main?
It'd probably be, I guess, a mix between electric vehicle chargers and power conditioning systems.
Yep.
Another side, I suppose, of the PVI department, I might say, is we do AC coupled batteries as well. Mm-hmm. So the battery technologies is something I've been a big part of. I did lots of testing with our AC coupled batteries and getting them to work in standalone mode and with third-party inverters as well. So we had a cool method of making everything work together. And it was fairly generic using frequency ramping. So anything that's 4777 compliant will end up being integratable with our battery. Mm-hmm. So we'll be able to run whilst off grid, which is pretty neat. And yeah.
For those who are not familiar with frequency ramping, that's where when a battery system there's full charge and it's AC coupled to a charging source, that it communicates via changing the frequency of the grid very slightly. We use it here. That's, in fact, I call myself an accidental microgrid because we started off with a large centralized inverter battery system, and I wanted to test inverters, so I just connected them AC coupled to that grid. And then I started worrying about, how are we going to manage that charge? Sure enough, 4777 comes to the rescue. It just magically works. And it's been mandated since 2016 edition, so you don't have to modify the inverter even.
Yeah, it's perfect, isn't it? It just works out for everyone. It's, in the standard, so too easy. Yeah.
Yeah. Some people say there's, some appliances don't like that frequency change. My experience is basically the only thing I've noticed is that my coffee machine runs slightly faster during a frequency ramp, so the coffee could be a little bit bitter. And if I could find an old clock that was frequency locked to the 50 hertz, then maybe it would run a bit fast and slow.
That's an interesting thought. Yeah. Yeah, so and I guess some of the other things I'm working with at the moment is, I guess, keeping in mind our IEEE 2030.5. So that's been a big thing that's sort of coming through in South Australia, and I'm sure Western Power will eventually adopt that as well. And
This is a security protocol.
Yeah, so this is basically API implementation. It's an implementation guide. So using it's called the CCIP Oz as well, which is the Common Smart Inverter Profile for Australia. We're looking at trying to integrate with that and making sure that we can fulfill the new market requirements that are going to be coming through.
Yeah. Can you give an example?
So most of this is all for flexible exports and remote disconnection. So of course, if there's too much solar on the grid, sometimes inverters need to be turned off, or they need to be controlled so that there's not too much power in the grid when it's not needed. And an agent will then be able to control our inverters remotely and just ramp them all down or turn them off if need be.
If I remember correctly, 2030 IEEE 2030.5 also has some security implementations as well.
Yes.
Because I actually had the people from OLAB here just last week, and they were doing testing of a lot of the inverter systems here. And their comment was they were surprised how many don't even use HTTPS. They're just completely clear. So this is something that you are aware of and work with?
Yes, just mostly working with the R&D department, making sure the right people come together to implement that and make sure we've got everything secure and that everyone's data is safe and everyone's happy at the end of the day. So
I mean, when you think about it, all the IoT that's connected to the cloud is a risk if you don't have good security around it.
That's right.
You don't need to bomb a city, you just need to blow up their batteries. Or overcharging them.
That's true,
But, that's probably a bit unlikely. But, even just, misprogramming, that's another issue, and a whole bunch of, the flow on for that. So let's talk about power conditioning systems. So are you talking about charging a car battery or?
The power conditioning systems are usually for charging larger scale batteries for commercial purposes. So you might have a large commercial building and you'll need really big chargers to charge those batteries to support the building. And that's what we facilitate.
All right. So not a car battery charger.
Not a car.
Right. Okay. So big stuff.
Big stuff. 100 kilowatt, and I think we'll be coming soon with a 1 megawatt as well. So pretty big.
Right. And is at that sort of scale, power factor gets to be a consideration. Do you using kind of some smarts around that?
Well, we do actually have power quality systems as well that we sell. So I'm sure that'll be part of the solution. But we'll see how we go. It's sort of something that's for the really big stuff. We're letting most of the installers deal with that, or third-party integrators. But I'm sure we'll probably come up with a full Delta solution as well. We're definitely aiming our business to be more solutions-based as opposed to just being an OEM or just providing a product.
Great. So you're also quite au fait with the particular DC charger we have here. So shall we have a little tinker with it and see if we can get some stuff to happen?
Sure, let's have a play.
Okay, let's do it.
Cool.